All right. So we are in 5.6. Did you guys finish up 5.5 okay? Those were painful, huh? All right, so we are in 5.6, and we're trying to solve the double loggers. Got to finish 5.6 today. That'll be due tomorrow, is the plan. All right, so what's the game plan? So this one has a couple of logs and a piece that's not a log, right? So what's the plan when there's two or more logs? What do? It's the log countdown, right? So you get the logs on the same side. Get the logs on the same side, and then you combine into one log, and you lose the log. Base stays the base. Other two switch. So you remember that? I call all of this a log countdown, is what I said to try to help you remember it. So that's the plan, right? When you got a couple of logs, you get them on the same side and you combine them into one log. And then you lose that log. So it's basically two logs, one log, no log is the game plan, right? So your first step then is to grab this log here. Erase that. The first step then is to grab this log here and jump it to the other side, right? So we're going to have log of 7x plus 5 minus log of x minus 8 equals 1. Does that make sense? There's step number 1, get the logs on the same side. All right, so we got the two logs on the same side. And now combine those into one log. Right? So now you do the countdown thing, right? So you get them on the same side and you count them down. Let me give you a second to do that. So you want two logs, one log, no logs, right? On the three lines. So go ahead and give that a try. I'm going to run through working out. So, all right, so we have two logs. Now we're going to do the countdowns, right? So you have two logs here, two logs. Next line is going to be one log. So how do I combine these two logs into one log? The properties, right? Subtraction becomes division, right? So log of 7x plus 5 over x minus 8, right? Like that, right? Subtraction becomes division. That's the, and what if that had been a plus sign in the middle? Then I would have written 7x plus 5 times x minus 8. It would have been multiplication, right? Adding becomes multiply, subtraction becomes divide. Right? Those are the log properties. All right? So now it's one log. And so next line, there's going to be no log. So there's two logs on the first line, then one log. Now I want no logs. So here, let me go to a fresh screen here. Okay, so what was that? Log 7x plus 5. Oh, I can just do this right, yeah. So log of 7x plus 5 minus log of x minus 8 is 1. So that's two logs. And then one log is them divided. Okay, now how do I go to no log? So it's two logs, one log. Now I want no log. So how do you go to no log? Yeah. Yeah, you lose the log. Whenever we lose the log, the base stays the base. The other two switch. I call that the golden rule of logs. That's the main rule we use all the time for logs. When you lose a log, the golden rule says the base stays the base. The other two switch. So who's the base? What is the base? Yeah, right? There's an understood 10 there, huh? You lose that log, the base stays base. The other two meaning what? All the other stuff. All that whole x fraction and the 1 trade places, don't they? Instead of 10 to all that x stuff, it's 10 to the 1. And all that x stuff goes to the other side like that. Is that going to be kind of scribbly there? All right, good to there? No log, right? So now we just got to solve that equation. We're out of the log world, right? We're done with logs. Now we solve that equation. How do you solve that equation? Yeah, 10 to the 1 is just 10. you can multiply this, or you can just put this over 1 and cross multiply. Same thing either way. You can just multiply both sides by x minus 8, the denominator, or you can just cross multiply. Whenever you have a fraction on one side and a whole number, just put it over 1, cross multiply. Same result, either way. So it'd be 10x minus 8, 1 times 7x plus 5, distribute, 10x minus 80, boom, boom, 7x plus 5. So we got to subtract 7x. Right, when you have x's on opposite sides, get rid of one of them. What is that? 3x minus 80 is 5. Add the 80. That would be 3x is 85. Am I off the screen? Okay. And then divide by 3. There it is. 85 thirds. Is that good? Questions on that one? We all good? All right. All right. So same game plan. Give it a try. So you got 2 logs again. So same kind of thing. Count down the logs. 2 logs, 1 log, no log. On this one. Two logs, 1 log, no log. So 2 logs, 1 log, no logs. Okay, so 2 logs become 1 log. The base doesn't change, right? The log base 3, that never changes. We never do anything with that. So when I make them 1 log, it's going to be x plus 17 times x plus 11, right? Adding becomes multiply, doesn't it? Just like on the last one, subtraction became division. We good? Good so far. So 2 logs, 1 log, whoops, 1 log, and now no log. So how do I make it no log at all? You lose the log, the golden rule of logs, right? You lose the log, the base stays the base. The other 2 switch. All this x stuff and this 3 trade position. Instead of 3 to all the x stuff, it's 3 to the 3. And all the x stuff goes over there. Oops, we good with that? Getting more and more comfortable? All right, so now 3 to the 3rd is 27. Got to FOIL this side out. X squared plus 11x plus 17x plus some big number, 171.87. Thank you. Okay, so what are we going to do with that? What do you do when you see x squared with an equal sign? Get a 0. Get a 0, right? Whenever you got x squared with it, you get a 0, and you try to factor. Now, if it won't factor, we're going to have to go to the quadratic formula. I don't know what will happen here. Robert, are you telling me this one doesn't factor? I don't even know. Say 28 plus 160. Oh, good. Yeah, nice. Yeah. Everybody good to there? So whenever you see x squared, everybody okay with that game plan? Whenever you see x squared, right away you think, okay, get a 0, right, and then factor. Yeah, that one does factor. Good job, 20 and 8. That's right. Now, if it doesn't factor, you have to do the quad. We haven't had one of those yet, so I won't mess with it. So, yeah, so we're supposed to say what multiplies to be 160, what adds to be 28. Yeah, it's 20 and 8. Good job. Good job. Yeah, so both plus, huh? So then the answers are negative 20 and negative 8 in the end, aren't they? But I think one of those probably won't work, right? Remember, you always have to check which one's no good. Yeah, negative 20, because if you put negative 20 back in the original, it would make the inside of that first log, negative 20 plus 17, make it negative 3, right? It would be the log base 3 of negative 3. And you can never have negative or 0 inside of any log. Remember, that's the big no-no. That's where the vertical asymptotes always are on log graphs, because you can't have that, right? So any answer that makes the inside of a log 0 or negative is no good. The negative 8 is okay, because even though it's a negative number, the inside of the log is, right, because this would just be log base 3 of, what, 9? And this would be log base 3 of 3. Yeah, so it's okay. It doesn't make the inside of any log negative or 0, so it's acceptable. So the only answer is the negative 8. Is that good? Look, you guys can do those? No questions? All right. Be really ugly unless I'm missing something, and I could be missing something. So let's try this one. Let's see. I think there might be something new here. I mean, in general, it's the same thing, but I think it'll get ugly. I don't know. Give it a try. So same thing. Count down natural log, regular log, whatever. Same thing. Count down the logs. 2 logs, 1 log, no log. Yeah, it's gonna be ugly. Yeah, type in exact solution. Yeah, I don't see how this one's not going to be ugly. It's going to be ugly. See what you get. Okay, yeah, you're going to get e to the 5th. You guys getting e to the 5th? Yeah. Right? Unless I'm missing something. So 2 logs, right? You know the deal. Count them down. 2 logs, 1 log. So you got to combine those. It's adding, so that becomes times, right? Good there? Yeah. Adding becomes multiply, right? Right there. So x times, and then, so it's 2 logs, 1 log, and now you got to go to no log. And that means you do the golden rule thing. What's the base? E, right? Regular log base is 10 if it's not showing a different base. Natural log, it's E. Lose the log, base stays the base. Other 2 switch, other 2 means everything else, right? All that x stuff and the 5 trade. Instead of e to the x stuff, it's e to the 5, and the x stuff goes over there. Yeah, that's just ugly. Yeah. All right, then what? Multiply this, I guess. I don't know. Ugly. Yeah, well, we have an x squared, yes, with an equal sign, right? So what's the game plan whenever you've got x squared with an equal sign? Step 1, get a 0. Yeah, so we need to subtract that e to the 5th. E to the 5th is just a number, an ugly number, I'll grant you, but it's still just a number, right? It doesn't have an x. You with me? E's just a number, 2.718, blah, 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 to the 5th power. That's just a number in the end, like pi to the 5th or something. It's just a fancy, weird number. It doesn't have an x, though. Doesn't. It's just a number. Right, so get a 0. That's still the same game plan. Everybody good to there so far? So get a 0. Step 2, factor. Right? Not going to happen. Right? Say, here we are. Sure enough, we need the quad. Robert, you told me we didn't need the quad.
I don't think we did.
I can't see how we do it without it.
Yeah.
So try to factor. If it won't factor, quad time. Right? Let me go to a new screen. So we're going to have to do the quad here. Okay, so where are we at? What do we have? We have 0 equals x squared plus 12x minus e to the 5th. Okay, so 0 equals x squared minus 12x. Is it minus 12x? plus 12x minus e to the fifth. Okay, plus 12x minus e to the fifth. Okay, yeah, so the game plan with x squared, where should I write? Over here. The game plan with x squared is step 1, like I said, get a 0. Step 2, really it's try to factor, but now, and we know, and you already knew, not everything factors. If it won't factor, you can do the quad, negative b plus or minus the square root of b squared minus 4ac all over 2a. Good thing to put in your 3x5 card if you don't have it already memorized. So that's what we need to do. So let me come over here, negative b plus or minus the square root of b squared minus 4ac all over 2a. That's what x will equal. So yeah, when they don't factor, so whenever you have x squared, you get a 0 and you try to factor, but if they won't factor, you got to do the quad. So we got to do the quad, yeah.
When you put it in for c, would you put the e exponent 5?
Yeah, e to the fifth is c. Yeah.
Yeah, that's right.
Yeah.
I remember seeing it now like that.
Oh, sure, now.
It's been so long since I did this.
You swore to me under oath that there was none of these. All right. So, yeah, Robert's like 10 sections ahead or something. I was working with you.
I was like, how do you put that in there as a decimal? Well, no, you do just put it in as e.
Yeah, that's why they're saying they want exact answer. If you read the blue, it says type in exact solution. Meaning they want the e to the fifth thing. They don't want the decimal. Yeah. All right, so here we go. A, B, and C. Remember, the A, B, and C are not the x's. They're just the numbers next to the x squared, next to the x, and whatever number comes at the back, right? E to the fifth is a number. Negative, I should say. E to the fifth is a number. All right, here we go. Negative b. So negative 2. You remember this from algebra. It wasn't quite this ugly, though, in algebra. Negative b plus or minus square root of b squared minus 4 times a times c, negative e to the fifth, all over 2a. All right, so x equals negative 12 plus or minus the square root of, what's that, 144 plus 4 e to the fifth. Ooh, what just happened? Come on. Very good. There we go. All over, it's kind of moving around on me. All over 2. Good so far? Everybody good? See how the positive? Because negative times positive times negative. 2 negatives, positive. 4 e to the fifth, right? We're good to there now. Does Math Excel just want me to type that straight in? Not quite. This is where it's a little painful. I would probably be fine on the test. I'd say you got it. That's good enough. But they're going to be a little picky. They want one little step. Question?
What is the positive again?
Yeah, because the 2 negatives. So 2 negatives multiply to be positive. So, right, because these 3 guys are multiplying each other. So, okay, so now the trick on this one. Did you know that we can't, well, let's just do this. Rather than say what we can't do, let me show you what you do. You factor, within here, you got to factor the 4 out. What does that leave? 70, 36? Like that. Okay, and then the root of that 4 is going to be a 2 in the front. Like this. All over 2. Then there's another trick, if that's not enough for you. We good? Everybody see what I did to there? I looked at these two and said, hey, I can factor a 4 out. And then the root of 4 is just 2 in the front there. See how I rooted the 4? And I put a 2 in the front. Now, why do I care about all that? Now, yeah. Now, can I just cancel those two? Good, I'm glad you know that. I hope you all know that. You need to for calculus. Let's talk about it for a second. Remember my mantra that I try to help with? Plus and minuses are glue, like Costco. Shop it in Costco, right? You can't buy just one. You can't go there and say, I just want one milk and cut the plastic. You can't do it. That's what pluses and minuses are like in algebra. They glue things together, bond them. So that means this negative 12 and this plus or minus, that's a double bond, is glued. It's glued, which means you can't buy just one side of the glue bond. You buy both, or nothing. All or nothing, like Costco. You buy them both or nothing, right? So I just buy them both. So this becomes minus 6, and this is just 1. That's what you do them both, and it's fine. That good? So the answer then is minus 6 plus or minus the root of 36 plus e to the fifth. Over 1, but we don't need to show that over 1. There it is. And in fact, actually, we're going to have to type both those in. So right, don't they want, oh, but the negative one's going to be no good. Oh, yeah, there's a lot of trickery on this problem. Because remember, the inside of a natural log, you can't put a negative, or any log, right? The minus option there, you understand what I'm talking about? It's minus 6 plus root of 36 plus e to the 5th. That's the only answer. The minus option will be thrown out because that'll be negative. That's some negative number. You could find it on your calculator. It's got to be negative because it's negative 6 minus some more. So it's got to be negative. And you can't put negative in the original ln x right there. No way. So the negative option is out. It's just the positive one. And you think, is that positive? It is. This root of 36 plus e to the 5th, you know that's bigger than 6, because the root of 36 is 6, and we're adding more. So that's negative 6 plus something more than 6 is positive. It's some positive number. So there's our answer. That was some fancy algebra we had to do there, huh? Is everybody okay with that? Do you see that? Robert wanted to skip that one. It's like, that's an easy one. Negative 6 plus the root of 36 plus e to the 5th. A lot of little algebra rules. That's the kind of stuff I'm always saying, calculus, you want to master all those little algebra rules for your future. What do negative powers do to things? As we go into this problem, set your mind ahead of time. What does a negative power do on something? Flips it, right? All right, so try that one. So count down the logs. 2 logs, 1 log, no log. You're going to end up having negative powers at some point. And remember, that flips things. They're testing if you know that. So 2 logs, 1 log, no log. So count down the logs. 2 logs, 1 log, no logs. All right, you know the rules. The base remains the same, log base 1/7. And it's subtraction. Subtraction between 2 logs. You know that becomes division, doesn't it? Like that, right? Subtraction becomes division. Now lose the log. All right, so you lose the log. The base stays the base. The other 2 switch, right? The golden rule of logs. So the 1/7 stays the base, and these guys switch. Instead of 1/7 to all that x mess, it's 1/7 to the negative 2. Right? There's the negative power I was mentioning. So what is 1/7 to the negative 2? Flips it. It's just 7. Oh, sorry, 7 squared. Yeah, it's going to flip it, and then positive 7 squared, positive 2 is 49. We good there? So the negative part of the negative 2 flipped it to be 7/1, and then 7 squared is 49. Does that make sense? So negative powers flip, and then you just do the power. 7 squared is 49. All right. You know what to do now, right? Put 49/1, diagonal, diagonal, cross multiply. Yeah. Oh, good question. Yeah, not right now. I know what you mean. I mean, that looks good, and it probably will drop out. You don't want to cancel x's in the middle of the problem vertically, because anything that made the denominator 0 will never show up as an answer. Yeah, it's it's not a bad idea you have, but there's a technical reason why could be problematic. So cross multiply those. Okay, so what was it? So 49/1, x squared plus x squared minus x, okay. So 49/1, x squared plus x over x squared minus x. And diagonal, diagonal, 49 x squared minus x 1 times x squared plus x. Okay, distribute. X squared plus x. Good to there. All right, now we see x squared with an equal sign. What's the game plan? Get a 0. So we got to get a 0 on one side. So subtract x squared and subtract x, right? To get a 0. And this will be 48x squared minus 50x. Right, because that was 1 and 1. 49 minus 1 is 48, and negative 49 and negative 1 is negative 50. Oh yeah, that's easier. It's only 2 terms. It's not the like 2 parentheses, is it? It's just take out what's in common. Right, what's in common, like 2x, I guess? Or 4x, yeah, 2x, I guess. 24x minus 25. So then you set each part that has an x equal to 0, remember? Right, because if 2 things are multiplying to equal 0, either one could be 0 to make that true. Right? So then divide by 2, x is 0. This one, move the 25 over. 24x is 25, divide by 24. So the answers are 0 or 25 24ths. Now, are those both really acceptable answers? Remember, you always have to check logs. Is 0 an accept? If you put in 0 for x in the original, it's going to make the inside of that log 0. And that's not allowed. You can't have 0 or negative inside logs. So that's out. So it's just the 25 24ths. There it is. Is that okay? So we didn't have to use the quad. All right. Just one step. I mean, I just always see those and I think, oh, I can show them quick. One step. I'll just go right there, right there. I'm not even going to move things around. I'm going to kind of break the normal rules I do about getting a 0 and all that because I'm just seeing a quick way to the answer. I'm just saying, look, they're all log base A's, right? So just combine the left side, subtraction becomes divide. Combine the right side, subtraction becomes divide, right? And then just drop the logs by logic, like we talked about yesterday, right? If the log of something is the log of something, those somethings must be equal. So I didn't really follow the traditional path here. You could have, just would have been more steps. This is quicker, and now you know what to do. Diagonal, diagonal, blah, 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 solve the thing. That good? So just do that. Just combine the logs, and then drop the logs by logic, not by dividing. I didn't divide there. I just said, hey, if the log of something is equal to the log of something else, those somethings must be equal, or the logs of them wouldn't be coming out equal. All right. Okay, so 6 to the x equals 2. Let me let you go ahead, give you 30 seconds. Solve for x there. Thea, did you want to do it on the board, or?
No.
I just thought maybe you look like you wanted to. Okay, maybe later. Yeah, this is kind of a trick one, isn't it? I mean, have we done it before? Honestly, I can't remember. Like I said, I get confused with my finite math class where I'm doing kind of log stuff too. Did we talk about what to do in this one? Have we? What do we do? Sure you're not just a head, Robert? You already know?
No. We talked about it.
Do we?
Take a look at both sides.
Log both sides, yeah. Because we got to get that x out of power. Right. You see, how else are you going to get that x to come down out of the power zone? You can't divide by 6 or something, right? Yeah, that's the trick, and it's hard to remember. That's why I gave you 30 seconds. I'm hoping just it'll sink in better when you realize, oh yeah, on the test I don't want to do that. I don't know how to do this thing. I got to remember when x is in power. So when x is in the power zone, take ln, or regular log, either one will work. It doesn't really matter. I'll just do ln of both sides. Remember that? Because of that great quality that logs let the powers come down. So take the ln of both sides, like that, and then this power can come down. Remember that third quality of logs? Yeah, I did the whole dethroning, Hitler, World War II, right? Didn't I talk about all that? Right? Oh, it's all coming back now, right? All right, so yeah, that whole thing. When x is in power, you got to get it out of power. Natural log. Yeah, all right, then it's easy, huh? Now just divide by ln 6. Right, okay, so we have done that, yeah. So there it is. That's what they want, an exact solution. They just want that. They don't want a decimal. They say exact solution. So there it is. Good on that?
What did you use ln instead of log?
Yeah, no reason. The answer log 2 over log 6 would work just as well. The same decimal if you work them out. Now, there is actually a reason I use ln in general, is because every now and then they throw an e in these problems, and ln fits hand in glove with e. So I say, why don't we just use ln all the time? And we won't have to change our mind. It just works for everything, and beautifully when there's e. All right. Messier. Basically, it's going to be what we did before, but quite a bit messier. The algebra gets messier. All right, so let's try this one. 9 times 3 to the 9x is 8. So right away, you're thinking some kind of log, or natural log, but not quite yet. You know, you got to divide by that 9 first, and you got to get the base to power thing alone before you ln both sides. So let me write that. When x is in power, the whole dethrone it thing, first get the base alone, and then ln both sides, or regular log. Yeah, that's the whole thing. So first thing is I'm going to divide by the 9, because I'm trying to get the base alone. Like that. So now the base is alone, and then ln both sides. That's really the point of this example. Like that. Then the power comes down. The greatest quality of a log that they do that. Right? They dethrone powers. We don't have anything else that does that. And then, now how do we finish from here? Sometimes I know students get kind of confused at this point, but really I think they're not realizing ln3 is just a number. That's just a number. That's just a number. Just divide. Those are just numbers. Just divide by the 9 and the ln3, and the 9 and the ln3, and that's our answer. They want it just like that, exact solution. Is that good? So get the base alone and ln both sides when x is in power. So any problem you see on the next exam with x in power, get the base alone and ln both sides. Is that okay? There's messier ones. Can we move on? Got that one? All right, so 4 to the 1 minus 8x is 7 to the x. So right away we're thinking, all right, x is in power, ln both sides. The bases are already alone, so let's ln both sides right now. That is correct. Ln both sides. And then the power comes down. The power comes down. That's the great quality of logs, that they bring powers down. We good to there? Now we got a little more mess to deal with. Not a lot. Remember ln4, ln7, those are just numbers, right? So just distribute that number. 1 times ln4 is just ln4 minus 8 ln4 times x. You don't have to have parentheses, but I just trying to make it clear. Yeah, you don't. If I'm throwing you off, you don't need those parentheses. Just times x. So we're just saying that's just all a number. We're just trying to get x alone. We good so far? I just distributed the ln4 times the 1 times the 8x. Yeah, I kind of wrote it in a funny order, didn't I? It doesn't matter. You put it any order you want. Maybe it's probably better to put the 8x in the front. That way there's no chance to think the x is in the ln. Anyway, any order's fine. All right, so now, we're trying to solve for x. We're done with the power. Everything's out of power. We dethroned everything. How do we solve for x now? What do we do? Yeah, remember these? When you have x in 2 spots, yeah, you have to get them on the same side, factor out x, and divide. Remember that whole thing? So you just got to grab, it doesn't matter which side, just grab this one, for example, and jump him over there. So ln4 is x ln7 plus, right? I'm basically adding 8x ln4 to both sides. Tracking with me? Does that make sense? When you have a couple of x terms, get the 2 x's on the same side, factor out the x. That's how you isolate it. You have to do this a lot in calculus. There's a whole section in Calc 1 where you got like 3 or 4 or 5 terms, and like 2 of them will have x's. So really, that you'll need to know how to do this. You'll have to get those two x ones alone and factor out and divide. Boom. There we go. They want an exact answer. They want it typed in just like that. Good? Questions on all that? So same thing, just a fair bit more messy, huh? Because there's a couple x's. Questions I can answer? Sure you guys don't have questions? I was just talking to a student in office hours, and she was telling me about another student in a different class that has all these questions but never asks. Please, I used to ask my teachers all the time. Please ask or grab me after class. I'm glad to help. That's what I'm paid to do and glad to do. Grab me. I did. There's nothing shameful about that, I don't think. Yeah. I don't have time, Carlo. No, I'm just
Why did you put the negative 8x in the front and then the ln4? You kept the ln4 there, just didn't do anything. But the other one you put ln4 and you actually multiplied it.
Where are we at? I'm losing you. Where are we at?
You're one up.
In the distribution of the natural log.
1 minus 8 and 4.
Yeah, right here.
Yeah.
What did I do? So I distributed the ln4 went to the 1 and it went to the 8x. Oh, like what position I put it in? Oh yeah, it doesn't matter. You could put the x in.
Why wouldn't it have been 32x?
Oh yeah, good question. Really good question. Yeah, because he's in the toaster, he's out of the toaster. No interaction. Really good question. Yeah, that's perfect. That's the kind of stuff that, me too. When I was a student, I had all those same questions, and once I got those straight, my understanding grew. Yeah, good question. That 8 is in the toaster. I'm sorry, that 4 is in the toaster. That 8 is outside, so there's no interaction. He's plugged into a function. He's buried. That's why I'm always using that toaster thing to think about. You wouldn't reach into a toaster, right? It's in there. That ln4 there, he's in there, and the 8 can't get in there. What about the what?
What about the 1 then? Why would that one be put in?
Oh, that 1 is just right there in the front.
Yeah,
He never went in either.
That's actually what I was just gonna say right
Yeah.
now, is if you can imagine that there's an invisible number in front of the natural log.
Yeah,
would
that's
be
it.
1.
That's it. Good way to say it, Robert. There's like a 1 there. And it just hit the stuff in front of the natural log. Nobody went in there. Yeah, good question. That's true of any function, though. That's a valuable insight because it applies to sine, cosine, tangent. Any function you're going to deal with, you can't go in. You just hit the front when you multiply a function. On that. Good. About that. Okay, so first off, see how it says graphing utility. So now it's not by hand. So log base 7 x plus 2 minus log base 2 x minus 1 equals. Now why? Why can't we solve it by hand? How about that first off? Different bases. See how the different base. We don't have any rules for different bases like that. Now, how are you going to combine those two? You can't say, oh, subtraction becomes division. Not unless the bases are the same. 7, this is log base 7, that's log base 2. We cannot combine those, huh? So, it's just too hard to do by hand. So what do? You let y1 equal that side, you let y2 equal that side, you graph it on your calculator, and you do the intersect routine. Remember how to do that? Intersect, and you hit enter, enter, enter. Intersect, at least on the TI-84, which most of you had. Casio, it's a little different. So y1, y2, graph it, intersect, enter, enter, enter. You find the answers. All right, so I'll leave it at that. Grab me after class. If you have trouble with the graphing calculator, I'd be glad to help you. Just take a second. All right, let's try their fancy pi e problem. All right, so you know what to do. ln both sides, dethrone those powers, right? And then start dealing with all the mess. And the ln of e, what is the ln of e? 1, right? That just vanishes.
Okay. Does it say pi? Does it say pi?
Yeah, it's pi. Isn't it pi? Yeah, pi to the 1 minus 4x. Yeah. So when you type in the answer, you'll have to use, they'll have an option for typing in pi. You'll have a pi. You're not going to put in 3.14. You're going to put in the actual pi symbol, right? It's a Greek letter. It's a Greek P in the Greek alphabet. Hey, it's almost Pi Day. March 14th, 3/14. It's a little weird, but it is, yeah, it's soon, isn't it? They always have a big, San Francisco usually has some kind of a parade, I think. All right, ln e, that's just 1, goes away. Distribute the ln pi. Remember, the stuff just hits the front of the ln pi. So it's 1 times ln pi minus 4x ln pi. Nothing goes in the function. 7x. Okay, what do we do now? Got x in 2 spots. Get them on the same side. So grab this term and jump it there. So ln pi, this guy just comes down there, equals 7x plus 4x ln pi. And you know the drill, factor out the x, like that, and then divide both sides by the 7 plus 4 ln pi. And there's our answer. Ln pi over 7 plus 4 ln pi. So those are all pretty much the same, although they're missing. All right, so this section, 5.6, is due tomorrow. We finished up 5.6. So that is due tomorrow. Thursday. Tomorrow we do financial math problems. I think we're going to do some economic stuff. Have a good day. Hang out if you got questions. Thank you.